Proper maintenance of water level instruments on a boiler is crucial to keeping your plant running safely and efficiently at all times. We're going to demonstrate how to conduct a proper blowdown procedure on a boiler water gauge glass and a remote level indicator. But first, let's understand the purpose of these vital level indicating instruments. The water gauge glass on a boiler enables the operator to visually observe and verify the actual water level in the boiler. However, if not properly cleaned and maintained, a gauge glass can seem to show that there is sufficient water when the boiler is actually operating in a low or low water condition. Lack of maintenance may result in a stain or coating on the inside of the gauge glass where it is in contact with the boiler water and give the appearance of an incorrect level indication, especially if the drum level happens to be outside the range of the level instrument. Be sure that all plant procedures have been followed, and the control room operator is aware that a blowdown of the level instrument is about to take place. This will prevent any false trip of the boiler or unexpected drop with level indication for the primary control operator. Before conducting this procedure, inspect the installation. If any leakage is observed around the instrument or isolation valves, determine the source of the leak and make the repair. Then proceed with this blowdown procedure. The importance of proper cleaning and maintenance of the water column and the water gauge glass or level indicator cannot be stressed enough. The water column and connecting piping must be kept clean to ensure the water level in the gauge glass accurately represents the water level in the boiler. The frequency and method used to blow down a level instrument may affect service life and performance of the water column, gauge glass, or level indicator. At a minimum, we suggest weekly blowdowns on gauge glasses and monthly blowdowns for level indicators, with a maximum duration of 20 seconds. Excessive duration of blowdown time will shorten the life of the gauge glass or level indicator. However, plant rules will determine the actual frequency required. The user may also consider the quality of their boiler water as an influencing factor to determine the blowdown frequency. Furthermore, operators must consider proper blowdown procedures in order to keep the connecting water piping clean, even if the glass or level sensors remain clean for extended operational periods. Simply opening and closing the drain valve on a level instrument to conduct a blowdown will not ensure that water is flowing freely from the boiler drum through the water piping to the level instrument. However, by conducting the blowdown in this manner, the water that is in the instrument will drop and go out the drain, but there is no assurance the water leg piping between the boiler drum and the level instrument has been flushed. This is because the steam and water are both flowing from the outlet of the open drain. By following this procedure, the operator will ensure that steam and water both flow freely in this piping by testing them independently. The intent of this part of the procedure is to remove any debris or sediment from the water leg piping. While the risk of developing a blockage in the steam piping is very low, the risk for sediment buildup in the water piping is much greater over time. After following the blowdown procedure for a gauge glass or remote level indicator, the operator can be assured the steam and water connecting piping will be thoroughly flushed. We will now describe the recommended procedure for blowing down water level indicating instruments on a power boiler that's been constructed to meet the requirements of the ASME Boiler and Pressure Vessel Code. Please note, isolation valves between the drum and the water column, number 1 and number 3, are optional by code. However, if they are installed, they must be locked open under normal operating conditions. The drain valve number 5 on the water column is required by code. Using this drain valve alone is not a sufficient method to flush all the steam and water piping. This valve will remain closed during the following procedure. To begin the blowdown procedure, close the steam valves number 1 and number 2. Next, with water valves number 3 and number 4 in the open position, open the drain valve number 6, and the water will discharge. Water will be flashing due to the elevated temperature. This discharge from the water leg piping should be observed flowing out of the drain. The drain must be routed to a safe location, away from the operator. The drain piping may be routed to a condensate tank or a location away from the instrument, which may require a second individual in order to validate the flow. After 20 seconds, close the water valves number 3 and number 4. Then, open the steam valves number 1 and number 2, leaving the drain valve number 6 open. Steam will flow through the gauge glass and the drain valve outlet. After an additional 20 seconds, close the drain valve number 6 and open the water valves number 3 and number 4. The blowdown procedure for a gauge glass configuration has been completed, and the indicated water level should promptly return. If the water level does not promptly return to normal, the connecting piping may be partially clogged and need to be physically cleaned. To begin the blowdown procedure for a power boiler configured with a remote level indicator, first, close the steam valve number 1. Next, with water valve number 2 in the open position, open drain valve number 3, and the water will discharge. After 20 seconds, close the water valve number 2. Then, open steam valve number 1, and steam will blow through the remote level indicator and the drain valve outlet. After an additional 20 seconds, close the drain valve number 3 and open the water valve number 2. The blowdown procedure for a remote level indicator has been completed, and the indicated water level should promptly return. If the water level does not promptly return to normal, the connecting piping may be partially clogged and need to be physically cleaned. Finally, as an important safety tip, operate all of these valves slowly. This enables the operator to carefully observe the valves and instrument while conducting this procedure.